Welcome back, everybody. This is part 2 of 6 in my lecture series on graphing functions by transformations. In the previous video, we looked at our 7 parent functions. That's going to be really important for this video, so if you haven't seen it already, please go back and watch it. In this video, we're going to talk about translations and how to use them to sketch the graphs of functions quicker. Let's get started. A translation is a fancy name for sliding it around. So if I've got something that looks like a function plus c, that graph is going to exactly match y equals f of x, but it's going to be shifted vertically by c units. So for example, if I had, we know for our parent functions, I've got y equals x. Well, y equals x plus 2, I also know from previous videos, is going to be this line with slope 1, so it's going to be parallel to this, but with y-intercept 2. I just move it up 2 units. The same thing can be said when that constant c shows up in the input. So if I've got a function where the input has a constant being added or subtracted to it, that's going to be a horizontal shift. The only weird part about this is it's actually going to shift the opposite direction you would expect. Let's take a look at a couple of examples. Let's start with a vertical translation, since those are a little bit simpler. Let's sketch the graph of f of x equals root x plus 2. The very first step that I like to do with these problems is, first of all, what is the parent function? For this problem, and I'm gonna actually move my graph over to the side a little bit so we got a little more room to work. For this problem, that would be y equals root x. Basically, which of those parent functions from the previous video are showing up in some way in this function? And this one looks almost like root x. So what I'm going to do is I'm going to sketch the graph of the square root of x with a dashed line, because that's not actually going to be the graph that I'm looking for. And I know a couple of points on there. If I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in 4, I get 2 back. Okay, so there's my original, and I'm going to label those points here. 1, 1, 4, 2. And you can verify that those points live on the graph by taking the x values and plugging them in to see what y values you get. After that, since I have a translation, I want to shift 2 units up, since my 2 is positive. So 0, 2 moves to, 0, 0 moves up to 0, 2. 1, 1 is going to move up to 1, 3. And 4, 2 is going to move up to 4, 4. And that would be the sketch of the graph in yellow. Let's try another one. This time, though, I've got a horizontal shift, because notice the input is being affected. For starters, I have the same parent function. My parent function is root x, so I can graph that guy really quick. Same parent function as before. Those are the points 0, 0, 1, 1, 4, 2. But now I've got a horizontal shift. So I claimed earlier that I actually want to move backward. And that is true. Here, I've got a shift of 2 units. Now, you might expect to go right since the 2 is positive, but I actually want to go backward 2 units. So I go left 2, and 0, 0 ends up at negative 2, 0. 1, 1 ends up at negative 1, 1. And 4, 2 ends up at 2, 2. And that would be the sketch of the graph. Now, why do I go backwards? Notice here, when I start from 0, if I plug that in, I'm actually taking the square root of 2, right? So I get displaced forward. So to match it up, I shift backward, if that makes sense. Now I've got one for you to try, but you'll notice that first of all, my input on this function has a constant, and my output has a constant. So I've got both a horizontal and vertical shift. Pause the video here to see if you can tackle it on your own. If you need a hint, let it play a little longer. Ready for the hint? My parent function in this case is t squared, because I've got, at the end of the day, a quadratic to graph. So I have sketched the graph of the parent function here by plotting a few points that belong on it. Next, I notice that -3 on the input. That tells me I need to shift 3 units right. Again, opposite of what you would expect when it's a horizontal shift. And then I've got a -2 on the outside, which tells me I need to shift down by 2. It does match what you would expect. See if you can take it from here to finish sketching the graph. Now, you'll have to forgive me here a little bit because I am awful at drawing pictures. But I do know that to get the picture, I need to shift everything right by 3 and down by 2. So I have moved each of those 5 points right 3 and down 2 to get this picture. And for the record, as far as exams or things like that go, this is what I want to see. I don't need a perfect picture. In this video, we learned how to graph translations. That's going to be one of the major transformations that we learn on how to sketch the graph of functions quicker. In the next video, we're going to talk about reflections. Catch y'all in the next one.